Welcome to AI News Digest 2026-0609. Today's 5 stories. Story 1, Artificial Intelligence News ScienceDaily. Story 2, Official Google AI News and Updates Google blog. Story 3, Improving Multimodal Reasoning via Worst Dimension Optimization. Story 4, Some Hypotheses on how chatbots work in problem-solving driven conversations. Large language models as confirmation of the innovation illusion. Story 5, Land cover and flood type govern the detection limits of satellite-based flood mapping, Prithvi 02-0. Story 1, Artificial Intelligence News ScienceDaily. A new theoretical paper published on Archive in June 2026 is making a bold claim about the fundamental limits of large language models. Authored by SFM Van V. Lehman and H.D. Lethe Jr., and submitted to the journal Transmathematica, the 42-page paper argues that chatbots are not and cannot become genuine thinking partners capable of matching human problem-solving ability, and that further scaling of LLMs won't change that. The core of the argument rests on what the authors call metaphorical problem propagations, a framework they've developed to describe how humans think through and transform problems using mental models drawn from cognitive linguistics, neuropsychology, and psychology. Their hypothesis is that the text datasets used to train LLMs only partially capture this kind of human cognition. As a result, LLMs don't actually encode human thinking. They encode an artificial imitation of it, one that looks convincing on the surface but lacks the underlying cognitive machinery. This puts the paper firmly in the camp of AI skeptics, and the authors openly align themselves with Yann LeCun, the Meta AI chief who has repeatedly argued that current AI systems fall far short of animal or human-level learning. LeCun is directly quoted in the paper, noting that animals and humans exhibit learning abilities far beyond what current machine learning systems can achieve. The practical implications here are significant. If the authors are right, then businesses and individuals using chatbots to drive innovation, solve complex problems, or augment decision-making may be experiencing what the paper calls the innovation illusion, a false sense that AI is contributing meaningfully to cognitive work when it is, in fact, recycling patterns from its training data without genuine understanding. That said, this paper has real limitations to keep in mind. It is entirely theoretical. There are no experiments, no benchmarks, no user studies. The concept of metaphorical problem propagations is novel and has not yet been validated by the wider research community. And the paper focuses on basic chatbots, which may not fully represent the capabilities of frontier multimodal systems. Still, the paper's social and political framing is important. The authors acknowledge that chatbots are already being used at massive scale by individuals and organizations worldwide. Whether or not LLMs ever achieve true reasoning, understanding their actual mechanics and limitations matters enormously for how we deploy and trust them. This paper is a serious attempt to build that understanding on a firmer theoretical foundation. Story 2, Official Google AI News and Updates Google blog. As floods become more frequent and severe under climate change, the ability to rapidly map inundated areas from satellite imagery is becoming a critical tool for disaster response teams around the world. A new study published on Archive in June 2026 takes a hard look at how well AI-powered satellite flood mapping actually performs across diverse real-world conditions, and the findings are a mixed but instructive picture. The research, led by Venkatesh Kalaru and a team of 8 scientists from NASA and affiliated institutions, evaluated Prithvi 02-0, a geospatial foundation model trained on large satellite archives. The model was tested against 19 flood events it had never seen before, spanning 6 continents, 8 climate zones, and 6 different flood mechanisms, from riverine flooding to flash floods, covering events between 2017 and 2025. This kind of out-of-distribution testing is the real measure of an operational AI tool. The headline finding is striking. The model's performance depended enormously on what kind of land was being flooded. Croplands produced the best results, with an intersection over union score of 52%, and riverine floods were the most reliably detected, reaching an F1 score of 0.69. But when it came to tree cover and built-up urban areas, the model nearly failed entirely, achieving an IOU of just around 4%, regardless of what type of flood was occurring. That is a more than tenfold performance gap based purely on land cover. This matters because urban and forested areas are often where floods cause the most death and destruction. Disaster response agencies need to know that a tool performing well in agricultural plains may be nearly blind in a flooded city or jungle. The researchers also identified 23 distinct failure modes in the detection pipeline, and crucially, most of those failures came from pipeline engineering problems, data handling, preprocessing, and integration issues, rather than from fundamental limits in the AI model itself. That is actually good news, because engineering problems are fixable. Another important insight came from validating model outputs against two independent reference flood maps. The researchers found that some apparent model errors actually reflected disagreements between the reference products themselves, meaning the ground truth used to judge AI performance was itself inconsistent. This is a significant methodological caution for anyone using AI in high-stakes domains. Poor scores don't always mean the AI is wrong. The bottom line is that geospatial AI has real promise for flood response, but its limitations are environment-specific and need to be clearly communicated to the agencies relying on these tools. Story 3. Improving multimodal reasoning via worst dimension optimization. A new research paper out of Archive, submitted in early June 2026, tackles a problem that sounds technical but has very real consequences for anyone relying on AI systems to reason about the world. What happens when an AI is great at logic, but quietly terrible at understanding what it's actually looking at? The paper is titled Improving Multimodal Reasoning via Worst Dimension Optimization, and it comes from a team of 5 researchers including Heye-Cheng LV and Huiping Zhang. The work targets what are called process reward models, training systems that teach AI not just to get the right answer, but to reason correctly at every step along the way. Here's the problem the researchers identified. Current process reward models score AI reasoning by averaging performance across multiple dimensions, things like visual understanding, logical consistency, and factual accuracy. That sounds fair, but it creates a dangerous blind spot. If an AI model is very strong at logical reasoning, that strength can dominate the training signal and mask the fact that the model is actually quite bad at correctly interpreting an image. The model gets rewarded anyway, it never gets corrected, and you end up with a system that builds beautiful, coherent logic chains on top of faulty visual premises. It fails silently and confidently. The solution the team proposes is called worst dimension optimization. Instead of rewarding average performance, you focus the training signal on whichever dimension the model is performing worst at. Force the model to confront its weakest link, rather than letting its strongest capabilities paper over the cracks. This is a concept that will be familiar to anyone who thinks in terms of risk management or adversarial robustness. A chain is only as strong as its weakest link, and a system optimized for average performance is not the same as a system optimized for reliability. Why does this matter? Because multimodal AI is increasingly being used in high-stakes environments, reading medical scans, helping autonomous vehicles perceive the road, analyzing scientific data. In those contexts, a single reasoning failure can invalidate everything downstream. If this paper's results hold up under peer review, worst dimension optimization could become a standard part of how we train reliable multimodal AI systems going forward. Story 4. Some hypotheses on how chatbots work in problem-solving-driven conversations. Large language models as confirmation of the innovation illusion. This paper examines fundamental limitations of LLM chatbots as conversation partners in problem-solving contexts, drawing on cognitive linguistics, neuropsychology, and aggregation dynamics. The authors argue that chatbots may reinforce an innovation illusion, the false sense that novel solutions are being generated when they are not. The work touches on alignment-adjacent concerns about user over-reliance and misplaced trust in AI outputs. Story 5. Land cover and flood type govern the detection limits of satellite-based flood mapping, Prithvi-2.0. Researchers deployed the Prithvi-2.0 Zero Geospatial Foundation model across 19 out-of-distribution global flood events to evaluate its operational reliability for disaster response. The study characterizes how land cover type and flood characteristics affect model detection limits, providing important benchmarking data for AI in geospatial applications. This is a concrete example of foundation model evaluation in a high-stakes, real-world domain.